Hi, my name is Vlad Chuta and my topic is nanobiotechnology. The reason I chose this topic is because from a young age I loved anything that was science fiction based or futuristic. So naturally, when I hear nanotechnology, I think of a robot completely made up of very tiny robots or a storm composed of these nanorobots that would devour everything it touched. Before we dive into nanobiotechnology, let's start with the basics of what is nanotechnology and biotechnology. Nanotechnology is the study and application at a very small scale, in other words, at a nanoscale, across all other science fields that range from chemistry, biology, to engineering. Although before talking about biotechnology, let's quickly explain what a nanoscale is. Nanoscale is used when talking about nanotechnology, and to put it in a simpler way, a water atom is 0.1 of a nanometer, an antibody is 2.9 nanometers, a bacteria is 100 nanometers, the hair width is approximately 80,000 nanometers, and lastly, a tennis ball is 70 million nanometers. Precision measuring of atoms can be accomplished through carbon nanotubes created by nanowire. The nanostructures can be measured much more precisely when tightly packed yet neatly organized in rows, allowing for them to be much easier noticed signs that we would be looking for in the tested cells. Also, in case we still don't know what biotechnology is, let's quick run over what that is. Biotech is the study of advancements in technology in order to improve those things that affect us directly. In other words, this can involve the process of machines that help us to study the human DNA, but not the creation of those machines. Now that we have gone over all the material needed before we dive in, nanobiotechnology is the use of biological material as a starting block at a nanoscale. By doing this, we can recreate cells able to do anything we desire. Also, we are able to detect and diagnose any abnormality in our cells, whether they be diseased or spare cells. Although who came up with such a radical idea of working at a nanoscale in order to get the results desired? You could say the first spark of this came from a talk titled "There's Plenty of Room at the Bottom" by physicist Richard Feynman at an American Physical Society, where he spoke of a process where we would be able to control atoms and molecules. In detail, some of the other uses can be seen largely in medical and research fields, where we can use it to find cures and diseases. Along with that, we can do a multitude of new things, some of these being diagnostic applications, detection, individual target probes, and protein chips. I will go on to explain these and a couple more. Currently, most diseases are only noticed when symptoms have already appeared. Only then could professionals actually make a guess on what the illness is. In order for us to properly cure a person, we need to stop the disease way before this happens. We are capable of doing this through nucleic acid diagnostics, which thanks to nanotechnology has become a reality. In order to find the presence of those disease molecules, we usually take a sample and place it under a microscope, at which point we then use different dyes to figure out exactly what a scientist or doctor might be dealing with. With the use of nanotechnology, we can use semiconductor nanocrystals, also known as quantum dots, along with that. Protein chips could also be named DNA biochips, which are microprocessor-style tests capable of detecting most DNA protein abnormalities, creating a sort of specialized and so highly sensitive and specific test for us to probe for a specific DNA sequence that might be related to an unwanted trait or disease. In order to properly and quickly figure out what kind of cell we might be dealing with, instead of going through colorimetric methods, instead we might use nanogold particles. These particles are studded with short DNA segments that bonds with a like DNA, and so creating large clumps of visible gold balls, giving a much higher sensitivity test. Sparse cells are both rare and physically different from most usual cells, but they are important to detection and diagnosis of gene defects. Nanotechnology shows great promise to finding these by sorting these cells from regular cells by inserting electrodes through the microchannels and sorted depending on the amount of charge it held. Finding a needle in a haystack in terms of cell diagnostics just got a lot easier. Deciphering between all of the many cells and information in the cells can be accomplished with microfluidic chips. In other words, what this chip does is that as blood samples is placed on it, it will start to organize itself depending on the type of cell, at which point we can analyze it. Nanoneedles is the term given to a nanopattern surface made up of multiple silicone nanowires, enabling us to deliver vaccines and other such medicines beneath the skin without actual penetration of the skin, or without killing any of the skin particles. In other words, we are finding ways of administering shots without the need of needle part. One use that we can connect with something we have learned in class is using this nanobiotechnology and applying it as a skin for our prosthetic limbs. Many companies are coming together to build a flexible, integrated, lightweight, and multifunctional skin, or film skin. This will replace current prosthetic skin, giving the wearer the ability to feel heat, cold, and touch. Some of the challenges of this technology or barriers can be acknowledged and technical based. We are still in the very early ages of all of this, so if we want all the predictions for this technology to become true, we need to advance our current technology in order to then move forward with it. With all these great positive opportunities that this technology gives us, we may wonder what are some hazards of nanotechnology. Some hazards that people have mentioned is this idea that we shouldn't be playing God by going and changing and restructuring ourselves at the nanoscale. Although, like all new innovations, we should keep an open mind towards its benefits. Before we end the discussion, let's look at what the future of this technology will be. We see a big push for wearable nanotechnology based on gadgets able to keep us up to date on our body information. Also, as we find more and more about this technology, we'll be able to make more and more accessible to people, opening new doors for career opportunities. In the end, nanotechnology, when looking at it from a biotechnology perspective, can still be sort of interesting even if you're not involved in crazy robots. It's just a matter of looking at how far we have come in diagnosing diseases and enabling ourselves the ability to change DNA, at which point from here we can only go up.